studied the sp, d and f block elements. You also know about the long form periodic table, as it contains the 18 vertical column known as group and 7 horizontal columns which are known as periods. Now broadly the elements are classified in 4 groups, or it is categorized in the 4 types of elements. First type of elements are known as noble gases, or which present in 18th group, that we in matrix periodic table we call it 0 group element, and in long form periodic table it is known as 0 group elements. So these p block elements has complete p orbital as contain 6 electron in the p orbitals. The electronic configuration is ns2 and p6. In this, except helium, all the other has the electronic configuration ns2 and p6, and they are unreactive in nature because their octet is complete, or in case of helium the duplicate structure is complete. So these elements are known as noble gases. There are 6 elements present in this group, that is helium, neon, argon, krypton, xenon and radon. You have to learn their atomic number also. Helium atomic number 2, neon 10, argon 18, krypton 36, xenon 54 and radon 86. The next elements are known as representative elements. Representative elements are S and P block element. S block means first group element and second group elements are known as S block elements. First group element, also known as alkali metals, and second group elements are known as alkaline earth metals. They are mostly white or grayish white lustrous. They are soft, malleable, ductile and good conductor of heat and electricity. They are highly electropositive and possess very low ionization energy, means they easily form the cations. By losing one electron, first group element has the mostly show the valency +1, and second group element show the valency +2. So alkali metals show the valency +1 and alkaline earth metals show the valency +2, and they act as a strong reducing agent. Now these groups, first group and second group elements have metallic in nature. Now representative elements also S block elements. S block elements are mostly the non-metals. A few metals and some metalloids are also present in this group. This P block element, this 4, except 18th group, means 13, 14, 15, 16 and 17th group elements are known as P block elements, and they are mostly non-metallic in nature. The elements present down the group are metals and some have the metalloid characteristic. They show the mostly higher value of electronegativity and ionization energy. They show the low electropositive character. They usually form the covalent compound as they contain 3, 4, 5, 6, 7 electron in their outermost valence shell. So they easily shared their electron and formed the covalent compounds. Some of their compounds like halides are ionic in nature. Some of these elements show variable valency and exist in more than one oxidation state as tin, antimony, lead. They show the phosphorus also different oxidation states. Chlorine also have different oxidation state. Next, D block elements are also known as transition series. As these elements, transition elements are D block elements, they are present from group 3rd to group 12. In between the periodic table, in between the S and P block elements. The first transition series, as before I told you, is starting from scandium 21 and end with zinc 30. Second transition series is started from ytterbium 39 and end with cadmium 48. Third transition series, which include the lanthanides also, started from lanthanum 57 and then in the same group it will contain cerium 58 to lutetium 71. Atomic number 71. All 14 elements together kept in third group along with the lanthanum. So this here 14 elements of F block elements are also present here in the third transition series. In fourth transition series, here the D block is started from actinium, atomic number 89, and it contains the 14 element of thorium, F block element or actinide series of thorium 92, lawrencium 103 along with the actinium, and after that P block elements are present in this series and end with so what are the general characteristics of these transition series? They are mostly some of these elements act as catalyst, and here D block elements electrons are filled one by one, so mostly the electrons are unpaired in nature, means they show the paramagnetism. Next is these form the D block elements or transition series elements form the colored ion. As chromium, manganese, iron, cobalt, copper, they all form the colored ions. They show the variable valency and exist in several oxidation states. They are very good catalyst and they form the coordination or complex compound. Most of these metals form alloys as silver, palladium, platinum, gold, copper, iron, nickel, all are present in the transition series which are used to form the alloy. Next, F block element, which also known as inner transition elements, and it contains two series, lanthanide series and actinide series, as I explained before, N minus 2 F1 to 14 N minus 1 D 0 to 1 or NS2 is the electronic configuration of these elements. And these elements are metals and possess high density, high melting and burning points. And they are also show the variable valency and exist in several oxidation states in their compounds. Their ions are colored and paramagnetic in nature. They are radioactive in nature, and they also form the complex compounds. As we arrange the elements in the periodic table according to increasing order of their atomic number. Just now you have studied some terms as ionization, ionization, electronegativity, electron affinity. All these are the properties of the period. These properties has a general trend, means when we go across the period or down the group, they have the periodicity, elements have the periodicity in these properties. These properties are known as periodic properties. What are the cause of the periodicity in the cause of the periodicity is the extranuclear structure, means their electronic configuration. As you have seen that after certain interval, electronic configuration are similar, means after certain interval the electrons enter in the s block, then as s1, s2, then p block as p1, p2, p3, p4, p5, p6. So their electronic configuration is the cause of periodicity of the properties of the elements. So one by one we will study all these periodic properties. The first periodic property is the atomic radii. Atomic radii also govern the size of the atom. As atomic radii may be regarded as the distance from the center of the nucleus to the outermost valence shell of the element. Atomic radii we can, because according to wave mechanical nature or quantum nature of the electrons, the probability of finding the electron is not fixed. That's why on the basis of bonding of the electrons, we can divide the atomic radii in three categories as covalent radii, crystal radius, van der Waals radius, etc. So one by one we will study all these atomic radii. Atomic radii is the, in general we can say atomic radii is the distance between the nucleus to the outermost valence shell of the element. First is crystal radius, which is also known as metallic radius, because metals always, atoms are arranged in a metal in a particular way, and because of this they form the crystal lattice. So the crystal radius of a metal, which is also known as metallic radius, is half of the distance between the two adjacent metallic atoms or two adjacent atoms of the metal. Means in a crystal lattice, when the atoms are arranged, then the distance between the two atoms, half of the distance between the nuclei of the two adjacent atom is known as crystal radii or metallic radius. Next is covalent radius. When the bonds is covalent, means similar type of atoms are linked together and form the covalent bond. In covalent bond, overlapping of bond takes place. That's why this is the covalent radii is the half of the distance between the nuclei of two covalently linked atoms. Covalent radii is the smallest radii. Next is van der Waals radius. Van der Waals radius means when the atoms are arranged without forming any bond. So this is this half of the distance between the two nuclei of the adjacent atom when they are at their closest approach without formation of any bond. It means van der Waals radius is the largest radius and covalent radii is the smallest radii among all the three. As now, what is the variation of atomic radii in the periodic table? In the periodic table, as we move from left hand to right hand side, the electrons entered in the same shell. So, the nuclear pulls towards the electron increases from left to right, and because of this the atomic radii decreases as we move from left hand to right hand side in the periodic table. But the last group, this 18th group element, has the largest atomic radii in their period, because in that case their their octet is complete and they have stable electronic configuration. When we move down in a group, the atomic size increases, means atomic radius increases, atomic size increases as the number of shells increases in a particular group. So there is a regular trend in decrease and increase in the size of the atom as we move from left hand to right hand side in the periodic table. Atomic size decreases except noble gases or group 18th element. As we go down in a group, the atomic size increases because the number of shell increases. Next is atomic volume. Atomic volume of an element is defined as the volume occupied by 1 gram atom of that element. So Rothermere plot a graph between the atomic volume and the atomic number of the elements, and this peak and he formed the curve in which at the peaks all the first group elements, means alkali metals, are present at the peak of the curve, means they have sodium, potassium, rubidium, cesium, francium. These are found at the peak of the curve like this. In these peaks, the first group elements are present as they have maximum atomic volume. The less reactive transition metals metals like iron, manganese, cobalt, etc. are present at the minimas of the curve. Here, the transition metals are present. The electropositive elements are present on the descending slope. Here electropositive elements are present on the descending slope, and electronegative elements occupy the ascending slope. Like fluorine is present here, magnesium is present here. Means electronegative elements are present on the fluorine is present here, calcium is present here. So on the ascending slope, the electronegative elements are present, and on the descending slope, the electropositive elements are present. The elements having high melting point like carbon, silicon, iron, etc. occupy the descending slope. Now variation across the period. On moving left to right in a periodic table, atomic volume of the element first decreases and then increases. Means up to third group it is decreases, and beyond the fourth group it is started increases. Variation in a group. Atomic volume increases regularly on moving down the group. So this is the two properties, atomic radius and atomic volume of the elements. Now ions. How ions are formed? When atom lose one electron, it forms the positive type of ion that we call the cation. And as the element lose one electron, the number of electron decreases in the cation. So the nuclear pull towards the electron increases. That's why cation are smaller in size compared to their parent element. Anions when formed when the atom of the element gain one electron, they form the negative type of ion. Negative size of the anion or negative type of ion is more than or larger than the size of their parent atom, because when they get the electron, the nuclear pulls towards per electron decreases as the number of nucleons remains same, but the number of electron increases. That's why the size of the anion is larger than the size of the parent atom. Now variation of ionic radii in isoelectronic ions. What does mean isoelectronic ions? Iso means same. Electronic means electrons. Means the ions which contain same number of electrons are known as isoelectronic ions. So we can find out the ionic radii of the isoelectronic ions. It depends upon the magnitude of the nuclear charge. If the magnitude of nuclear charge increases, ionic radii decreases. So let us do some questions based on it. potassium plus. Minus 2 fluoride. Sodium or magnesium. Now, among these pairs, which of the following pairs would have a larger size? You have to explain which of the following pairs would have larger size in potassium and potassium ion. Potassium, when form the ion, it loses one electron. So, cation has the smaller size than their parent atom. It means potassium has more larger size, potassium atom has larger size than the potassium ion. Now, second is O2 minus and F minus. O2, oxygen, contain 9 electrons. So, in case of oxygen, oxide ion O2 minus and fluoride ion F minus, O2 minus would be bigger than fluoride F minus ion. This is because both contain the but oxide ion has less number of nucleons as it contains only 8 protons and it contains 9 protons. So, nuclear pull towards the electron in case of oxide ion is less than compared to the fluoride ion. That's why oxide ion is bigger than the fluoride ion. Next is sodium ion and magnesium ion. Sodium ion, sodium 11, by losing 1 electron, it has 10 electrons. Magnesium, by losing 2 electrons, it also contains 10 electrons, means they both are isoelectron. In the case of sodium, only 11 protons are present, means nuclear charge is less than the case of magnesium, which contains 12 protons. That's why sodium is bigger because it contains lesser nuclear charge. So I think it is clear to you among the potassium and potassium ion, as it is the parent atom. In case of when the parent atom form the cation, the size of the parent atom is larger, so potassium ion is larger. Oxide ion and fluoride ion, oxide ion both are the isoelectronic, both contain 10 electrons, but oxygen contains lesser nuclear charge. That's That's why oxide ion is larger in size. In case of sodium and magnesium ion, they are also isoelectronic, contain 10 electron both, but magnesium contain more number of nucleons or more nuclear charge. That's why sodium ion is larger in size. This is larger in size and this is larger in size and this is larger in size. Now next, you will study the valency. As all of you know, the valency is the combining capacity of the atoms. So when we move from left hand to right hand side in a group, valency first increases and then decreases. As 1, 2, 3, 4 till fourth group it is increases, and after that from 15, 16, 17 and 18 group, as nitrogen, oxygen, fluorine, it is decreases. Variation in periods on moving variation in groups. Same group contain the same valence electron, means the similar group contains similar type of valency. So there is no change in the valency in a particular group. Now next topic is ionization energy, ionization potential or ionization enthalpy.